Good morning, everybody. I know it's not quite 9 o'clock, but we're trying to squeeze about 2.5 hours worth of content into about 25 minutes. So I'm going to go ahead and start talking. Thanks for joining us this morning. This is my colleague, Craig McCabe. I'm Jeff Archer. We're both from the 3D content team at Esri. Craig has been working on indoor GIS projects for probably, about 6 years? And I've been dabbling in it for about 2.5 years. And last August, I liked it so much, I joined the team. So I've been doing it full-time since last August. And so yeah, we're here to talk to you today about some of the experience that we have in starting with CAD and BIM data and building indoor GIS and doing indoor GIS stuff, like making really pretty scenes and publishing those to the web and powering web applications and all that kind of stuff. And here's kind of a list of what we're going to cover. So I'm going to go through CAD and BIM as map data sources, and then cover kind of what are some of the caveats as using that as an indoor data source. There are some significant differences between the two, and we'll kind of cover some of that. And then I'll turn it over to Craig. He'll go through our new release of the Campus Viewer tools that's hot off the press as of last Saturday. And we'll look at some 2D and 3D indoor apps for mapping and doing other types of stuff too, primarily routing and all that. So pretty exciting stuff we got on tap today. You know, there's really been a lot of advances, I think, in the last 2 years, especially in terms of Esri technology specifically supporting direct read and import of CAD and BIM data, and also being able to make maps and scenes floor aware to be able to kind of switch back and forth between floors in a building. And one of the biggest things that's been an advancement that I've seen is the ability, you know, when you're talking about indoor GIS, in most cases the biggest challenge is you don't have any data. So you're looking at, you know, doing something for inside of a building or across a campus with multiple buildings and outdoor spaces. And the real problem that you have initially is that there's no GIS data, but there may be CAD data, or if you're really lucky, BIM data for several buildings or some combination of the two. One of the great things about the latest release of ArcGIS Pro is it's easy now, and also for desktop, it's really easy to just browse to a CAD drawing and add that as a data source to a map or a scene. And here we're looking at a couple of screenshots, and you can just literally, you can even drill into the CAD drawing and just select out like the polylines or the polygons or annotation or something like that. So that's a really nice advancement. BIM data, it's possible to do a quick import of just the visual components of the BIM data. The IFC specification for BIM is a really nice kind of intermediary. When you go from BIM to IFC, you can bring that directly in. And you can also use some other things like exporting BIM to multi-patches and bring that into the geodatabase as well. Basically what you're doing here is you're getting the graphic information into the platform. You can use that to build visualizations. And here's kind of a neat little flow chart put together by Don Kuehne, who's here with us today. How you can go from BIM, there's a couple of different options. You know, some of these intermediate formats, KML, 3DS, DAE. You can also use IFC and go through the data interoperability extension. You know, what you're looking for here is get to a multi-patch, and then you can directly add that multi-patch into a lot of the platform applications. And I'm going to exit here real quick, and we'll look at a couple of these things. So the first thing that we're going to look at, this is a web scene that was put together with BIM data from the University of Kentucky. And you can see there's an awful lot of interior furniture. We've got stairs and handrails and that kind of stuff. And I think we have, what is it, 5 buildings in this scene? Each building imported from a BIM model. So this is a way we can, you know, really kind of quickly get these things in with just maybe using an intermediate format, get the multi-patches, get those into the platform, and then you can publish this as a web scene and utilize that data. Kind of jump around here. So this is just, you know, visualization of the data that's coming from the BIM model. By default, we're looking at the exterior. We can also load the interiors. The internet right now appears to be getting hammered by everybody that's presenting, especially those guys doing 3D, man. They're using up all the bandwidth. So we can jump around here and look at some of the different information. So you can see we've imported a lot of the office furniture. We can get really detailed interior views using these BIM models as our initial data source. So, you know, pretty neat stuff. I mean, we can kind of navigate around here, see some neat things that came in. Like you can see individual beams in the ceiling, you know, the sinks and the cabinets and all that kind of stuff. Pretty nice. Now, another thing that's possible is to use CAD as a direct read. Here I just put together a map view in ArcGIS Pro, and I browsed to some CAD data and added it directly. And you know, just this can be really handy if you're trying to figure out like what kind of data that you have, where you're starting from with a project. If you have a CAD drawing, you can just add it to Pro and kind of look through and see kind of what layers are contained within that drawing, how they're named, what are some of the things you might want to pull out of that CAD drawing. You can even look at the annotation. You can see here the room numbers. These are annotation that I've added here in the scene. And when you add the CAD drawing, it's kind of nice. I already did it there, actually. I cheat a little. But when you go to where the drawings are located, you can just drill into that, and you can choose which type of layers you want to add from the CAD drawing. Then once that's added in, you can, let's say if I'm looking at the polylines for floor 3, I can open that up and I can see what each individual polyline layer is. So this is really kind of a valuable thing when you're trying to get your head around what your starting point is for building an indoor application. And in the campus viewer tools, one of the main things that we've included is a tool to do indoor CAD to GIS automatically. So once you have a good feel for what layers are in your CAD drawing and what you want to use to aggregate into, say, polygons into an interior space, you can use this indoor CAD to GIS tool to actually do that. There's really detailed documentation. I don't have time to go through the whole workflow here this morning, unfortunately, but there's really detailed documentation. If you look for the campus viewer tools, you download the zip file. This is step 1 in the process. We're also working on videos to kind of walk you through it, so if you're interested in that, definitely look it up. And go back to the slides here. I feel like I'm forgetting something. Oh yeah, so no, that's coming up next, actually. I'll hold off. So, you know, using these BIM as 3D objects for visualization, when we start to, you know, that's a kind of a quick tour of what you can do with CAD and BIM just as a direct read. Now, if you want to use that CAD and BIM data as a source for a GIS data set, things get a little bit more complicated. There's a little bit more homework you have to do. So in terms of CAD, you may see attribution that you really like in the CAD annotation. It can be kind of tricky to drill into the CAD data and find out like how do I access that block where this annotation is and get that value and put it into an attribute. That's one of the things we've actually built into the indoor CAD to GIS tool. It has logic built into it where you can, in one of the columns where you set up the configuration, you basically map all the layers in the CAD drawing to the destination feature class. One of the things you can do is to put in like which CAD layer contains the names for the interior spaces. And you can put that in there, and the tool has some logic to drill in and actually look for that annotation and then put it into an attribute in the output. So if you think about, you know, the spectrum of how you can import data from a CAD drawing into the GIS, you have on one end you have the CAD to geodatabase tool where you just get the visualization components, basically quick and dirty import into a geodatabase. On the other end of the spectrum you have the data interoperability extension, or FME, where you can come up with a workbench that really does a really detailed mapping of specifically this CAD drawing standard to this specific geodatabase, you know, model or whatever. The CAD to GIS tool falls somewhere in the middle. So it's designed to be something to allow you to get a much more advanced starting point, specifically for indoor data sets than you would just with, say, the CAD to geodatabase tool. So now when you talk about BIM, the BIM has things called properties and attributes. And if you just do like that intermediate kind of multi-patch import as a 3D visualization component, you won't get all of that stuff. And where the data interoperability extension in FME allows you to kind of map those properties and attributes into what the destination feature class attributes will be. But it's a little bit more work. As you might imagine, you have to go in, you have to create a workbench. Just getting the visual information, again, is pretty easy. getting the attribute information from the BIM model is a little bit more involved. So this is kind of the state of the art today. And if we take a look at what that looks like, if you start with a REVIT model, you can use the FME REVIT plugin to get to the RVZ kind of intermediate data set, and then use the data interoperability extension to get that. You know, you have to do a little work. You have to do some model builder stuff. Again, there's a little bit more of a manual component to bringing in BIM today. If you have other things, you can use the IFC specification as an intermediate kind of step to go from your other BIM models to useful GIS layers. Don, did you want to add anything to that? All right, great. I'm doing all right then. If it gets the Don Kuehne seal of approval, it's good enough for me.
Oh yeah, go to full screen.
Oh, full screen, sorry. There we go, that's better. All right, so a research project that we're working on is to make it a little more direct to get Revit as a directory data source. So similar to the way that you can browse into the, the CAD data in Pro, kind of pick out what you want, bring that in. This is something we're working on this year. Don't really have a speculation on when this might be available. Just wanted to kind of mention it as something to keep your eye out for. We really want to try to make it easy. This is all about indoor in this demo theater. So again, the problem is a lot of times data doesn't exist for interior spaces or for campuses, and maybe it's in all kinds of different formats. You know, the newer buildings have a BIM model that was delivered from the architecture company. The older buildings maybe not even have a CAD data. You may just have blueprints. So we try to come up with some tools to make that a little easier. And with that, I'm going to turn it over to my colleague.
Ooh, that's me.
Craig McCabe.
Great. You hear me okay? Yeah, okay. So Jeff covered kind of how do you get your data in to a GIS, and I'm going to tell you now what you can do with it once you have it kind of 3D enabled and in a geodatabase. So we released actually our second release of this Campus Viewer toolset over last weekend. So I'll give you the URL at the end of this so you can download it. But in that is included the CAD to GIS tool and workflow. Once you have your indoor data, one of the main use cases is, okay, how do I get someplace? So you can query, and now you want to route between the two locations. Historically, creating indoor network data sets has been kind of a pain because typically it's a manual process. You can't go to OpenStreetMap and get the indoor network for your building. So where do you begin? What's the data model you're supposed to use? Kind of lots of questions that users have. So we've created an automated approach to generating these indoor networks using a lattice. And I'll show you kind of how that works in a second. Next step is styling and publishing. And this could be for use in 2D or 3D applications. Obviously, the workflow is different depending on which way you're going. So we're going to focus on the 3D story, and I'll show you basically how much simpler it is essentially to do it in 2D. Because it's way easier to filter and query on a device, for example. And last up is configuring the web app. So as part of this template that we're releasing, we have a JavaScript 4.1 API web application. And it essentially takes all these layers, scene layers, feature layers, and other configurations, and you can publish a web app out that other people can use to locate places inside a building or on a campus. And as I said, route between those two locations. So the network, I think this is kind of a cool part of this template, and we're continuing to kind of work on and improve the tools, but I want to go through the process of how to create a network for a building. So this is building O and OA. This is our kind of development or our services headquarters in Redlands. And the first step is we apply this lattice. So it's a Tetrachus square lattice, basically a bunch of squares with an X's through them. And then we create what's essentially a wall distance heat map. And we do this so that we can, using the network solver, route through locations in the building that are kind of away from walls. People walk down the middle of a hallway when they're walking through a building. So we wanted to capture that in how we generate this network data set automatically. So you can see the hotter areas are where people are going to be congregating or walking. And so you want to kind of get that central path through the hallway. And so the network logic kind of helps the solver do that automatically. So what we get after we do a closest facility calculation for every office in this building, and we do it on a floor-by-floor basis, is this kind of spider web, or it almost looks like a wiring diagram or something that connects all of our spaces to each other inside a building, including kind of the building entry points on the first floor, because you need to be able to get into the building somehow and connect out to your exterior network. And so this is what the finished network looks like for O and OA. It's 3 stories. You essentially connect each one of these lattice-thinned floor networks with transitions, so stairs or elevators or fire poles or whatever you have in your campus. And then you do this for each building, and you can actually do all the buildings at once. It supports rotation, so if you have a rotation attribute in your building, it basically rotates the lattice to align with the orientation of that building. So you can see we have kind of a ranking or priority of pathways. You know, we don't want to walk through the parking lot, for example. We want to stay on our sidewalk paths, which are shown in blue. All of these thin lattices are in black, and the transitions are in red to connect the floors of the building. And so we can use these to generate kind of the common sense routes, as well as restrict according to accessibility, like stairs, elevators, slopes, well-lit paths, different parts of the network that we want to exclude or favor. So to give you a sense of how long it takes to generate the Esri campus network, I think we have about 750,000 square feet. We have 3 kind of large buildings on campus. OA is about 90,000 square feet. That took 50 minutes or so. So all in, for all the buildings on campus, about 4 hours, so not too bad. And very little manual intervention, which is the best part of it. So there's 2 tools for creating the network. The first one is how to generate this kind of lattice network that extends into every space in a building. And the inputs here are essentially the outputs of the CAD GIS tool. So we have our building polygons, our floor polygons, our space polygons, and our floor plan lines. The floor plan lines are actually used to cut the lattice where you can't walk. So it could be, you essentially get a list of all the different line types in your data, and you check, you know, columns, doors, or no, sorry, not doors, but walls, any kind of permanent furniture that you can't traverse through. So the next part of the process is you add in your transition features, which are stairs and elevators, your origin destination points, which are just the centroids of those interior space points. Generally, these are kind of your address locators for indoors. And then the network templates. And the first template is to kind of avoid the walls, as I was talking about before. It uses a wall distance attribute that gets calculated in the first step. And then the second step is the network template is essentially the final network. And so this has all the different restriction types that are supported in this network schema. So I talked about, you know, preferring elevators or stairs. We also have, you know, ADA kind of compliant pathways or well-lit, or kind of the primary secondary pathways. An example of primary and secondary is either the kind of not going into the parking lot unless you have to. So you're going to stay on a primary path, which would be a sidewalk, and then if you have to get to your car, for example, then it'll get you onto the parking lot and out to your destination. So the next step, and I'll just go to a pro project here that's part of this template. Here is the kind of 2D version. So we have a campus map, we have a campus scene, and we have a campus publishing scene. So in the campus map, we have this OA building. All of our kind of routing points are in white inside the building, and then we have our building entry points, which are in red. And these are used to generate that initial network. So the initial network looks like this, and we can zoom in and see that each of these little lattice segments kind of extends into the doorway. So one of the main I guess, limitations or parameters in creating the network is that you have to get through the narrowest doorway. And so that's pretty much driving the density of your lattice as the input. Next step, we have our kind of wall distance calculation. And so each one of these segments knows how far away from a wall it is. And that goes into the kind of final network calculation, which you see here. And so a lot of people see this network and they say, oh, that's kind of a weird looking network. Why don't I have one center line? It doesn't really matter what it looks like until you see the route. It's all about the route that counts, right? And so as you see, when I show the application, the routes are actually really good looking, and there's no kind of, you don't have to think about creating all this network data in your manual digitizing workflow, for example. So another quick plug here for working with indoor data is the range slider. It makes essentially filtering through your floor plans really easy. So each one of our indoor layers are part of this range, are range enabled. And so we can just flip up and down through our floors and easily kind of query and filter through the stack of our building.
Yeah, I just want to interject. The Indoor CAD to GIS tool adds the z-values. When you import the CAD data, it adds the z-values directly to the geometry, so you can bring it directly into Pro and it's 3D.
So I'm going to go to kind of transition into publishing now. We don't have a whole lot of time left, so move quickly. Essentially, we have a set of layer files. We have a rule package for converting a building footprint into both a wireframe facade, as we see here, so you can kind of see what the context of the floor information is with the height of the building. So if you just have kind of a third floor floating in space, you don't know how tall that building is. Is this the top floor? Is this the third floor example? And so we have a procedural rule here, and we can essentially, it's reading attributes about that building polygon that are coming out of the CAD to GIS tool. So it's height, the number of floors, so it can split that visualization. And then you can actually turn on walls, turn on windows, and kind of customize the facade version. So this is just a very simple rule that I wrote for just showing you basically how to create a procedural symbol, turn that into something you can publish into a web scene. So now I'm going to go to the web scene. So I've taken all this interior data for our campus. Currently, with this application, you have to publish by floor. So we've grouped each of these floor services essentially into a group layer in the web scene that the application knows how to turn on or off. So if I'm looking for somebody on the second floor, it turns on the second floor group layer, goes into an interior view where we can see this interior content, and then zooms to that area of interest. So this web scene essentially is containing all of the kind of foundational layers for our campus, and this unique ID is then used by the application to load in to the app and kind of navigate that campus. So I'll go to the config file right now. This is the JavaScript web app. And you can see there's a few different inputs. We have that web scene ID that we plug in. We have a floor picker. We populate these group layer names that we created in the web scene. We have some feature services. So these are point feature services. This one has essentially two parts. One is the actual point feature, and the other one is the related table. So we can look for an office, for example, which is related to that point feature, and then from that get the associated employee information from the table. So if we have any changes in basically where people are seated or moves, we can just update that feature service, and then the web application will render those spaces and take you to the right location with the up-to-date employee information. A couple of the things we have here is, there's not a whole lot of configurations here. We have the routing service, and so in the template we have instructions on how to create this routing service, how to publish it, and how to access it from the web application. And this includes our restriction types for prohibiting stairs or elevators.
And don't let this intimidate you too much. There's a very detailed document that goes along with this that kind of tells you what all these values are.
Yeah, essentially there's only really 5 inputs and then a bunch of different customizations you can do on kind of look and feel, colors, route lines, that type of thing. So without further ado, first of all, I'll plug the Campus Viewer Tools content item. So if you just search for Campus Viewer Tools in ArcGIS Online, make sure to check the desktop content little checkbox on the left. You'll find it. You can also go to bit.ly/campusviewertools, all one word. I'll show that in a later slide. But on this content item, there's a little preview here that'll take you to the public version of the application. And so we're loading up this web scene that we published. First thing we want to do is find somebody. So there's an interesting list of weird fake names that I published in an employee table here. So we'll go to Joe Tank's office. And so it turns on that second floor group layer in the web scene, takes us to Joe's office, and now we can do some routing. So I'm going to route from here, and I have a meeting in Q2, say Q2 West Conference Room D. So you can click on our destination point, and it returns a 3D route between those two locations, telling us the walk time, 2 minutes, 55 seconds, and the distance, 182.5 meters or so. Now, because we have these different restriction types supported in the network data set, we can just click this need an elevator button and get the alternate route if you need to take an elevator. So you can see now we're going into the kind of the elevator bank of M down to the first floor, out the door, and up to the second floor of Q again via the elevator. So very cool, basically merging all of these different 3D layers and services and supporting feature layers to create this application. The route time is actually very fast, and you end up waiting more for the 3D content to draw in sometimes than the actual route to display. So.
Well, and hopefully it's clear from everything that Craig just went through, like, we're just doing GIS here. I mean, that's just a plain old network data set. It's not any kind of custom thing that we put together. It's just GIS. So we're just happen to be doing it inside a building.
Right. So another thing to point out is there's categorized searches, so you can search for kind of all of your content, whether it's people, it could be equipment, maybe it's control panels. And so you can look for just people in our case, or rooms, or basically all of the different features that are published as part of the application. So you can add in any number of additional kind of categories of search into your application when you deploy it. So so that's a quick kind of look at the web app. Another thing you may have seen in the plenary is this indoor routing example app by the runtime team. And so this is taking all of the same data that we're creating, the interior spaces and address locator points, as well as kind of the vector version of our base map, landscape information, and publishing that out as a mobile map package that's hosted on a portal. And so when you load the application, it checks for updates in that package. So if you have any moves, you can schedule updates to this package on your org. And then you do your normal search, find the route, and then kind of step through that route using the app. So another cool thing about the runtime app is that based on the building that's in view, it'll populate the floor picker accordingly. So if you're zoomed in on a 2-story building, you'll have 2 stories or 2 floors in the picker. If you're on a 10-story building, you'll have 10 floors. So it's pretty cool. So we're kind of in a transition period right now between the JavaScript 4.1, 4.2, and the 4.3 APIs. So the 4.3 API enables scene layer filtering, which doesn't sound that exciting, but
it's very exciting.
It's a real game changer for this type of work and a lot of other use cases, actually. So as I was showing before, with the 4.1, 4.2 APIs, we have to group by floors. That requires a lot of publishing steps. And just creating a web scene that has all those different floor group layers. I did a 25-story building with 3 layers per floor, and just dragging all those into group layers took me like a half hour. So this is the kind of the old world, and now this is the new world. So we publish a single, basically GDB with all our interior data, and then the API can do the filtering on those services using regular expressions. So show me, the second floor of building Q, or just show me all the buildings or all the floors that have an AD defibrillator device in them. So it's a really powerful way to filter through this basically dense 3D data in a web app. So I can just show you a very quick preview of that. I know we have to get out of here for our next presenter. So we'll do filter route. And we can take questions in the hallway as we're running out of time here. So this is a kind of a development sample for filtering. And so now we can go from, let's say, M3 East conference room. And we're going to do a route from here to Q1, let's see, East conference room B. So you can see now we don't see all the floors for all the campus. We just see our kind of origin floor in M, and then we see our destination floor in Q. So a very powerful way to just kind of show you what you need to know and not turn on all your interior data just to see your kind of location of interest. So I think we have 2 minutes, so I'll shut down here so our next presenters can come up here and set up. Sorry we didn't have more time here for questions, but Jeff and I are going to be right outside. So if you want to come up and ask us more questions, feel free to do so. We'd love to talk to you.
Yep.
And again, the link is bit.ly/campusviewertools. And so up here at the top. Great. Thank you very much.